I welcome Dr. N. Alagamurthy sir, Professor, Department of Mechanical Engineering, Pondicherry Technological University, and all the participants.
Your volume, madam,
Ma'am?
voice is not coming.
Lata ma'am? Okay. Okay, sir. I think ma'am, her voice is not audible. Okay. Sir, can I continue, sir?
Please.
Oh, yeah. Myself, Srividya, co-coordinator of this Atal FDP. I like to introduce sir. I take pleasure in welcoming an eminent personality like Dr. N. Alagamurthy in sir. He is a professor and former head of Department of Mechanical Engineering at Puducherry Technological University. He has 37 years of service in teaching, research, and academic administration. He has published more than 350 papers in journals and conference proceeding with H-Index 23. Under his guidance, 22 PhD scholars completed their research work, 179 theses were evaluated by Sir, and he acted as a DC member for 55 scholars. He acted as a member in various professional bodies, IQAC cells for several institutes. He acted as an expert committee member in NAC, MBA, AICT, and he is the chairman of State Government Approval Committee. He has acted as an academic and administrative auditor for various institutes and also acted as reviewer in various journals. He has acted as a technical committee member of some of the organization of Government of Puducherry. He is a coordinator for Centralized Administration Committee at Government of Puducherry. He is an observer in National Testing Agency, MHRD, for UGC, NEET, JEE, ICAR examination. He is the Technical Evaluation Committee member of Puducherry, Smart City, DRDA, and HRCE, and the Performance Reviewer Committee member of Karaikal Port and Expert Committee member of ITI at Government of Puducherry. I once again welcome Dr. N. Alagamurthy sir for this section. Now I hand over the section to sir. I welcome you, sir.
Thank you, madam. So, good evening to all of you, my dear young friends and colleagues and participants for this excellent Atal FDP program. So, good evening to coordinator Professor Lata madam and co-coordinator Professor Jai Chitra madam and other my dear participants and friends working in Dakshashila University.
Good
So
evening,
this,
sir. Some network problem in my side, sir. Good evening, sir.
Is it audible, madam?
Yes, sir. It's audible only, sir. Good
Okay,
evening,
okay.
sir. My some
Good
network
evening, good
problem
evening.
here.
Okay, madam. Okay. I will continue, madam. I will continue.
Yes, sir.
Okay. So that today, so this topic which we are going to discuss is vehicle to grid technology, V2G. I think so that they have given enough introduction about me. So this vehicle to grid technology, before going into that subject, I will give some brief introduction then, and then so that we will go to that so the other the important areas which are to be addressed in the V2G technology. There is always room for a story that can transport people to another place. So transport, it is a very important one nowadays. Without a transport, so we cannot survive, or we cannot do our functions and other work also. Okay, transportation, it is the center of the world, and so that it is the glue of our daily lives. When it goes well, we don't see it. When it goes wrong, it if negatively colors our day, makes us feel angry. That is the situation of the transportation. Modes of transport include air, land, rail, and road, water, cable, pipelines, and space. The field can be divided into infrastructure, vehicles, and operations. Transport enables human trades, which is essential for the development of the civilization. This is the second point. The first one is transportation. It is the center of the world, and the second important one is the for the development of civilization, transport it is required. Any businessman will tell you that transportation is fundamental to success for any business activity, trade activity, commercial activity, any logistics activity. So without so the transportation we cannot function at all. So therefore that fundamental to success is the transportation is the fundamental to success. If we were going to talk about transport, I would say that the great city is not the one that has highways, but one where a child on a tricycle or bicycle can go safely anywhere. So that is the fourth important point. Even though it is the fourth important point, safety is much more important than other thing. Development of civilization, it is a center for the center of the world, and the transportation it is fundamental to success, and the safety is very much essential. Thank you and appreciation to Takshashila University Management, Takshashila University Administration, and AICT Atal FDP for organizing this kind of program. Takshashila University R&D team, and then Takshashila University School of Core Engineering, faculty, staff, and students of Takshashila University, and much more than my dear participants and colleagues. Thank you for so this. August presence and then participating in this event, and my appreciation to all of you. So it is a very nicely organized program. So I surprised to see the various topics, nearly 13 topics. This coordinator Dr. Lata and co-coordinator Dr. Jayachitra, they are going to cover it in this 6 days from starting from 3rd onwards, 3rd February to up to I think some 7th or 8th they are having the programs. So really that topic, it is a wonderful topic, program on innovative solutions for smart cities, enhancing mobility and urban sustainability. It is a main theme of the Atal FDP, in which they are so that covering several topics. One is the hydrogen energy, importance of this hydrogen energy based mobility and backup power applications, and the empowering smart environments through renewable energy, and then digital platforms for reporting urban issues and civic engagement, cyber security and privacy in smart cities, vehicle to grid technology. So that is the fifth topic that which we are going to see today, and IoT solutions for waste management. So if at all any issues, please tell me, madam. Hello.
Sir.
Yes,
Yes,
sir.
sir,
Yes, sir.
sir.
Yes, sir.
Yes,
We'll
yes.
mute, sir. Mute the participants.
Hello.
We'll mute some of the participants are talking.
Okay. So that you give instruction, madam, through message you can give it.
Okay, sir.
IoT solutions for waste management, harnessing big data analytics to optimize urban planning in smart cities, the role of 5G in building smarter and sustainable cities, smart city ecosystems, integrating technology and community, smart traffic management, impact of electric and autonomous vehicle in urban environment, smart sensors and IoT for energy efficient buildings, IoT challenges and its application in smart cities. Such a wonderful program in which they are addressing nearly some 13 advanced topics. These are all very much essential and very much it is associated with all kind of engineering branches. It is not only for mechanical or for automobile sector. They are covering all the people who are in the engineering field. So it is such a wonderful program. So we have to really appreciate and thank the AICT also for allowing to permitting to conduct this kind of program. This is my table of content in which importance of transports already we have discussed, transport vehicles which are in use, issues in the present scenario, solutions for the issues, because only if there is a issue in the existing technology or in the existing vehicles, then only we will think about or we will go for some e-vehicles or hybrid vehicles. Even in the the hybrid vehicles and the e-vehicles also, there are several issues and several problems. One such problem or one such advantage is the V2G technology. Anyhow, so that we are going to discuss in elaborate. Solution for the issues, hybrid and e-vehicles, mainly e-vehicles, barriers in e-vehicles. Okay, what are the issues and the problems, disadvantages in e-vehicles? methods to overcome the barriers. Okay, because so engineers, we are here to provide the solutions. That is why I put that solution for the issues. Okay, there are several methods are available to overcome the barriers. Any barriers we can overcome in our life as well as in our day-to-day activities. Okay, so that we are going to discuss about the various methods and what are the advances in e-vehicles, in which the vehicle to everything. So that is the main advancement in the e-vehicle technology. Out of among which the V2G, it is the one of the important one. V2G technology and the final remarks. Okay. Importance of transportation, already I told you na, so it is mainly for the civilization development, and then it is the for any successful business. Without the transportation it is not possible. Transportation plays a vital role in connecting people, goods and ideas across the different regions. It enables the movement of individuals, products and resources, facilitating economic growth and development. It encompasses various modes of travel and infrastructure designed to facilitate these movements, whether it's commuting to work, delivering goods to market, or traveling to new destinations. Transportation is an essential part of our daily lives. So therefore, without the transport, we cannot survive, or we cannot perform our work, day-to-day activity. That is the situation. So there are some 7 to 8 points are there in the importance of transportation. Physical supply of products encourages specialization, mobility of labor and capital, brings stability in price, creates social and cultural utility, promotes foreign trade, encourages mass production. There are several types of transportation. So here so I am giving some very so that old pictures and the new pictures. Okay, the first one, it is road transportation, or it is surface transportation, rail transportation, air transportation, water transportation, the pipeline transportation. So normally, so in the industries and even in for transporting oils na, oils and then coals and some powders, chemicals. Okay, so industrial practices through the pipeline, they are transporting. Even water, it is transported. Water from one place to another place, water it is transported through pipeline only, because it is bringing a huge amount of water in some lakhs of liters in vehicle. It is very difficult. So therefore, they are moving in a pipeline. Okay, and there are other modes are also available. It is called the inter and multimodal facilities. Okay, there are several benefits are there, and why the transportation it is important. You know it, it is for the work, for the food, for the social socialization, entertainment, education, health and safety. The transport it is important. There are several benefits. One among the benefit is economic impact, social connectivity, access to goods and services, trade and globalization, tourism and travel, emergency response and disaster relief. There are environmental issues are also there connected with the present vehicle technology, or present the automotive sector. As transportation is a significant contributor to greenhouse gas emissions and pollution, there is a growing emphasis on sustainable transportation solutions. Therefore, we have to think about the alternative methods and alternative so the fuels. Okay, among which the one of the major alternative is the e-vehicle and hybrid vehicle. There are several issues are there associated with transport, mass transport also. So now we are going for some different techniques, and then for rapid transport also we are going for some different techniques. The development of electric vehicles, alternative fuels and improved public transportation systems aims to reduce the environmental impact of transportation. You see, so that the development of electric vehicles and alternative fuels and improved public transportation systems are the so that having association with this environmental impact. Investing in eco-friendly transportation options helps mitigate climate change, improve air quality, and promote a more sustainable future. There are several kind of vehicles are available in our world. Okay, more than, so I have taken this data only from the website only. There are more than hundreds of different types of vehicles. So here I have highlighted with some pictures and information. Vehicles include wagons, bicycles, motor vehicles, motorcycles, cars, trucks, buses, mobility scooters, railed vehicles, trains, trams, watercraft, ships, boats, underwater vehicles, amphibious vehicles, so screw-propelled vehicles, hovercraft, aircraft, airplanes, helicopters, aerostats, and the spacecraft. Okay, these are all the various types of vehicles. So that you know that the mainly the fuel it is used in the vehicle, whatever type of vehicle, some energy it is required. That energy may be in a different form. So that chemical energy, thermal energy. So these are all different form of the energies which are used for the vehicles. Okay. So here I have listed out the fuel which are used in the different vehicle type and fuel used. Combustion only vehicle, so it is exclusively the petroleum and the other fuels like diesel it is used. Micro hybrid electric vehicles, it is petroleum or other fuels but can shut off engine to consume less. Okay. And then there is a mild hybrid electric vehicles, so here exclusively uses a petroleum or other fuel but has electric battery to consume less. Plug-in hybrid vehicles, okay, uses mixture of petroleum or other fuel. Because I am telling about the hybrid mode. So hybrid mode means we can operate the vehicle with the regular fuel as well as with other type of system or other type of mechanism. That's why I am highlighting from the third onwards. Now it is the micro hybrid, mild hybrid, plug-in hybrid, all. So these three. Okay, so that we can go for the fuels, petroleum, diesel or other alternate fuels, and also we can go for the electric battery also. All electric vehicles, okay, so it is only the exclusively uses electricity from power grid. Okay, fuel cell vehicles, okay, exclusively uses hydrogen or hydrates, okay, other fuel to generate electricity. So why? So this vehicle transport it is important, so that various reasons we have discussed in the previous PowerPoint. But you see, so there are some several vital statistical informations are there about the vehicle statistics. Number of vehicles in operation across India from financial year 1951 to 2024, it is 0.3 to 410 in millions. You see, from in the last 75 years, so that we don't know, so that how many times it is enhanced or it is so that increased 0.3 to 410 in millions. Okay, so therefore fuel requirement it is one side, and another one side so that the production goes. Okay, and another one side so that we have to think about that environmental issues also. That is why, so I am putting this slide. Okay, vehicle statistics. In a country with the third largest road network in the world, the total number of vehicles in fiscal year 2024 stood at 410.3. So India, it is the third largest road network in the world. Okay, around some 410.3 millions vehicles which are in road. Okay, road travel seemed to be the preferred choice in India with around 60% of the population, because India it is so that it is a mixed variety of people. It is they are living from uh, below poverty line as well as the middle, so that middle income, lower income, higher income. Okay, so therefore majority of the people, 60% of the population, they are preferring the road transport only. Not only public commute, the industrial movement of goods through roads had also been on the rise, with nearly 4.7 billion metric tons of freight transported through roads in financial year 2019. Okay, so therefore not only for public movement, it is also for the industrial movement of goods also. So this transportation plays a vital role. And the demographics. So the youth in the capital city of Delhi preferred to use public transport with because for even for some for jolly and then for joyful, okay, people they are traveling. The children's young age groups they are traveling in the vehicles, the road vehicles, surface vehicles. In the southern cities of Hyderabad and Chennai, however, personal two-wheelers were vehicles of choice for the young generation. This affection towards the easily navigable two-wheelers was reflected in the sales volume, with an approximate 13.5 million two-wheelers sold in the country in the financial year 2022. So therefore, majority of the youth, they are preferring the road transport, even so that aged people also, they are using it. And so that the young generation, they want to use two wheelers, and then so that the sales volume also, it is getting increased in the financial year 2022 to 2024. But however, there is another one issue. So like, so this environmental issue, road accidents are also there. With the increase of motorbike sales in India, there was also a rise in the risks involved with them. With over 60.2 thousand road accidents by two-wheelers in 2024. Despite the downside, the number of motorcycles was likely to increase, make traveling within a mercilessly congested and not easily accessible network of roads within the large cities. So therefore, associated problem is the road accident and environmental issue. Why we have to go for alternate vehicles? Because we see, so we have seen in the previous slides, in the last some 10 15 slides, we have seen that so that transport, it is very much essential, very much important, and there are associated problems are also there. So that fuel consumption, it goes on increasing, and production of a vehicle itself, it is a very tough job. And then so this accident one side, and then environmental impact. So therefore, we have to think about the alternate vehicles or e-vehicles. Okay. So the advantage of this e-vehicles or alternate vehicle is it reduces the fuel consumption, improve the environment, intelligent and smart transportation. Electric vehicles and hybrid vehicles are both better for the environment than conventional vehicles, but they are not the only solutions to climate change. Okay, so there are other options are also available. There is a definite difference is there between the e-vehicle versus hybrid vehicle. Okay, so that the hybrid vehicle, normally we can go with some different kind of fuels, alternate fuels. But e-vehicles, it is electrically operated vehicle. Only these vehicle produce zero tailpipe emissions and are powered solely by electricity. So that is the main advantage or difference between the hybrid vehicle. There is no emission at all, and also it is mainly or solely it is by electricity. That is the first thing. And in a hybrid vehicle, these vehicles combine an electric motor with a combustion engine. So therefore, there will be some pollution problem will also be there. Okay. But so that the other advantages are there in hybrid vehicle. For higher speeds, the combustion engine takes over. Hybrids can also offer some environmental benefits, but they don't match the emission-free operation of EVs. Other factors to consider and include, so electricity source, okay, and then the source of electricity used to charge an EV can vary by region. In areas that use low polluting energy sources, EVs can have a life cycle emissions with advantage over conventional vehicles. There are problems with the electric vehicles, that the electricity source, getting electricity, that is one of the issue. And then charging infrastructure in a country like India, there are only about 2,000 public charging stations are there, while the number of EVs is expected to grow to 40 to 50 million by 2030. Okay, and then vehicle mix, that is another one problem in India. The vehicle mix is dominated by two and three wheelers, which have different charging requirements than four wheelers. So therefore, these are all the main three issues. One is the where we are going to get the electricity or the current, and then the charging infrastructure, and then so that the charging infrastructure for to meet out the different kind of vehicles, two wheelers, three wheelers, and then four wheelers, and even if some big vehicles. Madam, is it okay, madam? Hello?
Yes, sir.
Huh?
Yes, sir. Yes,
Okay,
sir.
okay, okay,
Yes.
okay. So because I don't know, so whether participants, they are keenly watching or not, they are following me or not. Okay, but anyhow, so I will continue. Okay, so India's vehicle face a number of problems, including air pollutions. One is the air pollution, and the second one is the vehicles in India emit significant amount of air toxins such as carbon dioxide, carbon monoxide, and nitrogen oxide. These emissions contributes to poor air quality in urban areas. You know that in every year, so that Delhi, Bangalore, Chennai, Hyderabad, Mumbai cities, Pune cities, they are facing lot of problems because of this the pollution. Okay, and again the second one is the road accident. A rise in road accidents involving unfit commercial vehicles is a problem in India. Okay. So therefore, these are all the reasons which we have to think about the e-vehicles and the hybrid vehicles. But anyhow, so that, in the e-vehicle, there are certain barriers are also there, and then there are certain advantages are also there. One such advantage is the V2G technology. Okay, concept of e-vehicle. Okay, of course. Okay, so that I think so. This topic it is not addressed. Okay, I am going. I am giving some basic information as well as some advanced information. Is it right, madam? Is it okay, madam? Because I saw your titles na, so it is different titles na, so therefore e-vehicle introduction they have not given. It is not addressed. But anyhow, so that I will quickly cover it. Okay.
Okay.
So that the electric vehicle. So it is so mainly so it is powered by an electric motor that draws electricity from a battery. Okay, and is capable of being charged from an external source. How does EV work? Here's a basic rundown of how electric car works. EVs receive energy from a charging station and store the energy in its battery. The battery gives power to the motor which moves the wheels. Okay, this is the basic fundamental of the e-vehicle. Okay, so there is a source from where there we have to get the electricity. That electricity it is stored in the or we have to store it in the battery. Then that battery supplies the power to the or energy to the vehicle. Okay, maybe it may be two-wheeler or three-wheeler or car. Okay, this is the basic functioning of e-vehicle. Okay, again there are several advantages are there about the e-vehicle. So advantages over traditional vehicles, it includes environmental, economic and operational benefits. Okay, driving an electric vehicle can help you reduce your carbon footprint because there will be zero emissions, zero tailpipe emissions. You can reduce the environmental impact of charging your vehicle further by choosing renewable energy options for home electricity. Okay, so there are several advantages are also there. Again, so I am listing out the various advantages of electric cars. Okay, and then I will come to that V2G or V2 everything. So before that, I want to show some informations also. Okay, running cost is lower than petrol and diesel powered cars. Low maintenance cost, emits zero emission and reduces noise. Tax benefits are there. Convenient to drive, easy to charge at home, convenient cabin space and more storage facility. You do not need to face fuel price hikes. Okay, so therefore every day, so that the prices, fuel price, diesel, petrol, so varies. So therefore there is no need to worry about it. Why EV is more efficient? Electric motors makes vehicle sustainability more efficient than internal combustion engines. Electric motors convert over 85% of electrical energy into mechanical energy or motion compared to less than 40% of a gas combustion engine. So therefore, so that even if you go, if you are replacing the diesel and the petrol with so the LPG or CNG gas, okay, so that e-vehicle it is a better so that efficient vehicle. Okay, that is a point which I want to share it with you. Okay, there are other barriers are also there in electric vehicle adoption. Okay, yes, I am coming to this main topic. Okay, there are some disadvantages or there are some issues, there are some barriers or there are some limitations in using the electric vehicle adoption. I think all of you agreeing that yes, so transport it is important and we have seen the different types of transport. So that in the transport there are issues, road accident and the fuel problem and then the environmental issues. So therefore we are going for the other options like electric vehicle and the hybrid vehicle. In the electric vehicle, how it works that we have seen, there are several benefits are there in the electric vehicle. But even then, so that the technology it is not coming up or it is not so that growing so that so in a larger scale, uh, The reason is there are several barriers are there. One such barrier is mainly the charging infrastructure, and then the battery disposal, because we are going to use the some battery. Okay, so therefore after the so that the life okay over is so suppose if it is designed for some 5 years or 10 years means then we have to dispose the battery. Okay, so therefore battery disposal it is a problem, and the charging time it is taking more time for charging a battery. Okay, so therefore even if you forget to charge it, then again it is a problem. Charging time, limited availability. So you know that so the battery we have designed it only for certain hours or for certain kilometers only. So therefore again it is a issue. Limited availability and the investment, high initial cost. Okay, range anxiety. Okay, so that there are okay companies they are coming with some different prices. Okay, so that one company they are saying it is some 70,000, 80,000, and another one company they are saying some 90,000, 1 lakh, 1.5 lakhs. So it is for the two wheelers. Whereas if you take the four wheelers, okay, so it is more than some 7 lakhs, 8 lakhs, 10 lakhs. It is coming. Range anxiety. Okay, and then even we cannot predict so to what extent this vehicle will go. Suppose whether suppose we are moving from Pondicherry to Chennai, whether so this my battery will can able to take up me from Pondicherry to Chennai, and then from Chennai to Pondicherry, some 300 kilometers, and then some internal movement. Okay, whether so that anxiety it is there. Okay, suboptimal battery technology, so that there are development it is going on in so that in battery technology, common issues with electric vehicles. There are other issues are also there in design and development, and mainly in materials also, in what kind of materials to be used. Okay, all these things are there, and even so that reducing the weight of the vehicle also, that another one issues. Okay, batteries account for a substantial portion of an electric vehicle's overall cost. Okay, so if you take some 1 lakh rupees means nearly some 50 to 60 percentage it is battery cost, because that charging infrastructure and the battery cost alone so plays a major role in the overall cost of the vehicle. Okay, lack of standardization, charging issues, lack of clean energy, consumer attitude. These are all the main barriers in the electric vehicle adoption. Okay, I hope that the participants they will appreciate me and they will understand that yes, so electric vehicle, okay, you even you can take up this as a project work or some research work for undergraduate and postgraduate to solve these issues. Okay, so that how to improve the charging infrastructure, that is one of your research problem, or undergraduate level or postgraduate level you can give some project. Okay, is it okay? Participants please understand. Hello. Hello.
Yes, sir, you are audible, but they will
I don't know,
reply.
because they are not responding now. They have to follow it along with me.
Yes,
Okay,
there
because
some.
these are all the major issues. So here I am listing out. There are some 15, 16 issues. These 15, 16 issues, if you are addressing, it will become a research problem. Okay, that is the emphasis which I want to convey to the teachers, because so this Atal, so this FDP program, it is mainly aiming for teachers. Okay, youngsters, young teachers, and those who are interested in some different technology, and those who are guiding some many students na, they can take up this okay issues, and then they can address it. Okay, yes, there are several advancements in electric vehicle technology. So one such advancement is the V2G or V2 everything. Okay, what is this V2 everything? It is vehicle to everything. Okay, so yes, we will discuss. So that again, okay, so that if you are addressing that barrier, okay, then that itself it is a advancements in the electric vehicle technology. One is improved batteries. Okay, nowadays people they are yes, battery it is a issue, disposal it is a issue. Now they are working on it, so that they are several improved techniques and improved batteries are available nowadays. Advanced driver assistance in the system itself, in the vehicle itself, there are IoT based techniques, and so that the modern techniques are available to assist the driver. Okay, so therefore it will give information. Okay, even so that there are works are available connecting the IoT, e-vehicle and the smart city. Okay, so that they are IoT giving information where the next charging station it is coming, what is the level of the battery, to what extent we will go. Okay, so then okay, all these informations now, so that the e-vehicle or that vehicle it is displays or giving information to the driver. Autonomous driving systems are innovations that enable drivers to drive in complete safety. Okay, that is another one major the advancement in the electric vehicle technology. Okay. And then silicon anode batteries are gaining attention due to their ability to store more energy than traditional graphite anodes. Okay, nowadays there are two, so that normally the traditional graphite anodes are used. Okay, but that storing capacity it is less, the energy storing capacity, electrical energy storing capacity. So therefore people so they are going for this silicon anode batteries. Okay, that is again another one interesting area in the V2G. Bidirectional charging. Okay, so in India, so currently we are having only a unidirectional or single directional charging the e-vehicle only. Okay, whereas in certain countries, okay, developed countries, there are vehicles, e-vehicles are available with the bidirectional charging. Okay, bidirectional charging and V2G integration, that is vehicle to grid technology integration. Vehicle to grid technology gained prominence. Even it is an interesting area. So therefore, one side we can attend the barriers. Okay, so therefore we can find out the solutions, and then what are the other options? Can I use this the electric vehicle or whatever the battery? Okay, can you use it for other purposes? Okay, because it is a battery, na, we can use it for home lighting, so that home domestic applications and other industrial applications, even for commercial applications, like that. I am coming to that point. Okay, General Motors is adding a capability called V2H. It is called the vehicle to home or bidirectional charging, to allow its new electric vehicles to send the power from their batteries to the owner's home. Okay, there are other advancements also taking place in e-vehicle technology. Battery management system, how to maintain or how to manage the battery, digital infotainment systems. The regenerative braking trend contributes to energy efficiency as it captures the kinetic energy released during braking. Okay, that also so that they are trying, so that so during the brake application, how to convert that so that sudden stop or that mechanical energy into electrical energy. That work also it is going. That is called the regenerative braking. Okay, the increase in charging infrastructure makes owning an EV easier by mitigating range anxiety and making EVs more practical for consumers. Okay, so if I am having a better battery and charging infrastructure, okay, so then okay, people without any worry, without any concern, they can travel even for some 500 kilometers, 600 kilometers. The major issue is only so that we are not having adequate the charging infrastructure or charging stations, and also that the batteries it is only limited for some time. Okay, and fast charging and longevity also again another one. So that advancement you can think about. Yes, instead of, suppose if I am keep so that charging it for some the battery complete charge, it takes some 3 hours or 4 hours. Instead of that, some half an hour, 1 hour, then it is better. Okay, similarly increasing the battery life, that longevity, then again another one advancement or interesting research area. Charging technology. This technology aims to recharge EVs over Wi-Fi by converting AC power into DC power, eliminating the need of physical charging. Okay, so therefore IoT nowadays it is used. Okay, or charging technology, so it recharges EVs over by Wi-Fi. It is by the internet options. Okay, electric vehicles and IoT in smart cities. In recent years, numerous people have been moving towards urban life. By 2030, it is estimated that more than 60% of the population will live in urban areas. Okay, so therefore, for the urban life, we are in the need of electric vehicles, because in the urban areas, population will be more. Okay, so then the environmental issues will be there, accident will be there. So therefore better to avoid the accident and reduce the emissions and other things, it is advisable to go for electric vehicles. But of course, so that the electric vehicle, there is a prominent components are there. It is battery and charging infrastructure. Whether can I use, instead of only charging the battery, can I get or can I use this battery for my home and for other application? That is the current topic. That is called the V2G technology. Okay, anyhow, so that I will complete it in another some 10-15 minutes. Okay. Further, the connection between different urban systems such as transportation, communication, networks, and trade is remarkably more complex than before. These complexities have doubled the significance of smart cities and the rapid adaptation of cities to the latest technologies. Okay. Electric vehicles and IoT in smart cities. Therefore, now the latest thing is yes, how, so that there is a smart city, there is a concept called Internet of Things, and there is a concept called e-vehicles. So therefore, how, so that connecting all these three, and the people they are doing a lot of work. Okay, the electric vehicle is one of the new components in the current era, that its application in cities can be considered an influential innovation for sustainable urban growth and development. On the other hand, with the expansion of electric vehicles in the transportation industry and the need for energy to charge car batteries, the impact of these vehicles on the network cannot be overlooked. Okay, yes. There are several the methods are available. In addition to this IoT, using the smart city and the Internet of Things platform, we can collect data on the behavior of electric vehicle owners, and with the deep learning method, which is one of the methods of machine learning, predict the charge level of electric vehicles. Therefore, the deep learning, if you are so that know about this deep learning, even we can adopt this deep learning method or the machine learning, AML, artificial intelligence and machine learning, to predict the charge level of the electric vehicles. Nowadays it is showing, indicating, but we can so that estimate exactly in the arrival to the parking, okay, the location of the car and the period of connection to the parking. Okay, all these information through this deep learning method, artificial intelligence, IoT, and smart sensors, machine learning, we can predict, and then we can have a better electric vehicle and a better smart city. Okay, there are IoT. This is what, okay, so I am telling the IoT solution for electric vehicle charging network. So connecting all India. Okay, so it is possible only by this okay, IoT, and then smart city, and then e-vehicle. Okay, yes. V2G technology. Yes, coming to this main topic. Before this, okay, V2G technology, I will show some of the other interesting, okay, so some report, okay, then you can understand, okay. Before that, yes, so that the government of India, are they giving any subsidy? Are they encouraging? So this e-vehicle, yes, they are encouraging. I will show some important informations, okay. Quickly I will so that open it, and then I will is it visible, madam?
Yes, sir.
So you see, so that Central Electricity Authority, so along with the IIT Mumbai, they are working on implementation of vehicle to everything. So not only it is restricted with only vehicle to grid, okay. So that they are working on vehicle to everything. So that vehicle to everything means, you see, so that the fundamentals of vehicle to everything, technology enablers and challenges. Okay, quickly I am so that you see here V2G, V2H, V2L, okay, like this, okay, V2V, vehicle to vehicle, okay, one vehicle to another vehicle also it is possible. That is, it is with the help of the bidirectional charges, so charging, okay. So therefore, this is one of the important report. So it is available in the net itself. You please note down. So if someone is interested, okay, to get more information, means it is V2X, it is V2 everything. Okay, this is one report. Okay, and the second one, Again, so it is a techno-economic analysis and recommendations for V2X implementation in India. So by the Central Electricity Authority and then by IIT Mumbai. Okay, so that they are okay. How to implement it? It is a 85-page report. The first one it is some 37 pages report, and this one some 85 pages report. Okay, you please go through it. Okay. It is around some 291. So in terms of PowerPoint, it is coming 291, whereas that report it is some around some 85 to 100 pages only. Okay. Again, it is only so that vehicle to everything, vehicle to grid, vehicle to vehicle, vehicle to home, vehicle to load. Okay, vehicle to building. Okay, like this. Okay, so it is called V2X, V2 everything. Vehicle to grid, vehicle to vehicle, vehicle to home, vehicle to load, vehicle to building. Okay. Yes. So this is again so that CEA, Central Electricity Authority, they were given a nice report, electric vehicles utilization for vehicle to grid services. Okay, so this report also available. It is a executive summary available for some available for some 37 pages. You can read this. You can get a lot of information. Okay. Again, so it is, I told you now, it is two different report, report 1 and report 2, 37 and 85, and it is available in the form of PPT also. Better the teachers who are interested in electric vehicles and so V2X techniques or V2X technology, you please, okay, make use of these PowerPoints, okay. Very interesting PowerPoint, okay. Again, there is a executive summary, so prepared by IIT Mumbai and then Central Electricity Authority in implementing so this vehicle to everything in India by 2030, so that they are planning for this V2X concept. So there is another one, so that the R&D sector, so that they are working on the e-vehicles. So please refer this website. You are getting, you will get a lot of information about this, the e-vehicle and so that the research and other things. Indian EV market. Okay, so that the website is it is on JMK Research and Analytics. They are doing a lot of work on the e-vehicles. Okay, please refer this. Okay, please note down. So it is JMK Research and Analytics. Okay. 8, 9, 10. These are all two important, three important. The press release by the government of India. You see, over 13 lakh electric vehicles in use in India. Okay, so it was a report received in 2022. Now, so that number it is increased around some 20 lakh vehicles are there. Okay, so therefore the central government they are working on. Okay, there is a Ministry of Road Transport and Highways. They are working on or helping for okay, so this adoption of electric vehicles, even so that it is called FAME, the faster adoption and manufacturing of hybrid and electric vehicles in India. Okay, it is a scheme called in 2015. Okay, so this concept, okay, the central government they are helping for several manufacturers who are interested in electric vehicles. So therefore the Ministry of Road Transport and Highways, okay, they are helping. Ministry of Heavy Industries also they are helping. So the scheme itself, I told you now, it is a 2015 scheme. Okay, so that here you see, so it is published in last 2023. Okay, so that the Ministry of Heavy Industries for a period of 5 years, commencing from 1st April 2019. Okay, with a total budgetary support of rupees 10,000 crore. Okay, this phase mainly focuses on supporting electrification of public and shared transportation and aims to support through demand incentive 709 e-buses, 5 lakh e3 wheelers, 55,000 e4 wheeler passenger cars and 10 lakhs e2 wheelers. Okay, so therefore government of India, so through this Ministry of Heavy Industries, okay, through this scheme called FAM India, FAME, faster adoption and manufacturing of hybrid and electric vehicles in India. This is a scheme. Okay, they are government of India, they are encouraging. Okay, they are spending nearly 10,000 crores. Okay. So here there are some informations. So that two-wheeler registered two-wheelers it is 45, registered okay it is 25. Total number of vehicles sold under FAME 2 it is 7 lakh 45,000 like that. You please read this information. FAME India scheme it is they are helping. Even if some teachers they are interested in going for some charging station, charging infrastructure, some battery research. If you approach the Ministry of Heavy Industries or Ministry of Road Transport, they are helping for several projects. Okay. The central government, Ministry of Road Transport, okay, Government of India, Ministry of Power, they are also helping Ministry of Power because they want to to have more amount of electricity. It is vehicle to grid technology, so therefore they want to increase the power for the grid. Okay, so that they are also so that helping for EV charging infrastructure and EV charging stations. Okay, for binary operation, for binary charging. Okay. So therefore Ministry of Power, Ministry of Road Transport and Highways, Ministry of Heavy Vehicles, okay, these are all the three agencies working in our country, okay, for the development of e-vehicles. Okay, there is a large scope is there because so that the government of India, so that they are spending nearly some 10,000 crores. Okay, if anyone is interested, some teachers or researchers, they can approach these three ministries for doing some work on e-vehicles. Okay, yes. Coming to this V2G technology, vehicle to grid technology allows electric vehicles to send electricity back to the power grid. Okay, so therefore, okay, so whatever, okay, while yes, so that the vehicle, okay, so that battery once it is charged means so some idle time we can use it for excess amount of so that the power to the grid. Okay, because by while running, okay, so that the battery get charged. Okay, and the regenerative braking system also it helps in charging the battery. Okay, so therefore there are technologies. Okay, it is to charge the battery. Okay, so therefore so that bidirectional charging, okay, we can send the electric so that the electricity back to the power grid. This technology can help balance the electricity supply demand, especially during peak usage timings. IIT Bombay is currently conducting two V2G field demonstrations. Okay, only the IIT Mumbai and there are some other institutes they are doing some research, very good research in V2G, along with this, the Central Electricity Authority, Ministry of Power, and then Ministry of Road Transport and Highways, and then with the Ministry of the Heavy Industries. Okay, with more frequent charging and discharging, V2G can impact on EV batteries lifespan. Vehicle to grid charging devices or DC chargers. With the ongoing advancements and a commitment to standardization, V2G could soon become a mainstream feature, empowering EV owners to be active participants in the energy ecosystem. Just I am so that V2X I told na V2 it is everything. That is why it is called V2X. V2X, V2H, V2B, V2L, V2V and V2 everything. V2X means it is vehicle to everything, encompasses all forms of vehicle to grid interactions. Okay, and the vehicle to home allows EVs to the electric vehicle, so supplies power to the home. Vehicle to building, okay, so even for larger buildings, even for some kind of apartment, okay, in countries like states, okay, and then Brazil, okay, they are having this kind of facilities, vehicle to buildings. Okay, vehicle to load refers to powering external devices or loads directly from an EV. Okay, vehicle to vehicle involves energy transfer between EVs. So vehicle to vehicle also we can transfer the electricity. How does vehicle to grid technology work? Okay, so it is simply by, so basically works by enabling electric vehicles to communicate and interact with the power grid. Okay, it is through a bidirectional charger. Okay, EVs cannot only draw electricity to charge their batteries but also send stored energy back to the grid when needed, helping to stabilize supply and demand. Okay, suppose if sometimes if you are not utilizing the vehicle, okay, then so that the battery, from battery we can send the power to the home, send the power to the another vehicle, send the power to the grid or to the buildings, okay, and to other loads also. Okay, the role of smart grids and chargers in V2G, because these are all the two important component. Smart grids and chargers play an essential role in V2G, enabling real-time communication and control of energy flow between electric vehicles and the grid. They optimize charging and discharging, because the charging and discharging it is there. Okay, ensuring grid stability and efficient energy management. Okay, communication between EVs and the grid for bidirectional energy transfer. Ensuring effective V2G requires seamless communication between EVs and the grid. Okay. So parallelly, I am showing some interesting photographs. You please go through that photographs also. You can easily understand. This interaction facilitates bidirectional energy transfer, allowing electric vehicles to charge from the grid or supply energy back when needed, enhancing grid resilience and flexibility. Okay. The requirement of smart technology and approval from a grid operator. These are all some issues are associated with the V2G technology. Regulatory approval it is required, and there are some prerequisites are also there. It is to ensure safe and efficient energy exchange, adherence to grid standards, and the protection of the electrical infrastructure. These are all the things which we have to take care. Yeah, so ensure safety, safe and efficient energy exchange, adherence to grid standards, and the protection of the electrical infrastructure. Bidirectional charging stations to manage energy flow. V2G systems depend on bidirectional charging stations managing the flow of energy between EVs and the grid. Okay, understanding the mechanics is cool, but why should we care? Let's get into the heart of why V2G technology could be a game changer. Okay. Why is vehicle to grid technology? It is important because several ways make V2G technology useful. Okay, balances supply and demand on the grid, especially during peak times, facilitates integration of renewable and energy sources by storing excess energy, provides backup power during outages, reduces the carbon footprint of the transportation. Okay, and one of the contribution to mitigating climate change. Okay, that is again that is a advantage of this the V2G technology. V2G contributes to climate change to mitigate the severity in several different ways. It reduces the greenhouse gas emissions, optimized renewable energy use, enhanced grid stability. Role in decarbonization, energy efficiency, and electrification of the energy and mobility sectors. Okay, these are all certain advantages in going for the V2G or V2X technology. Okay, integration of renewable energy and energy storage also it is possible with V2G technology or V2X technology. This integration enhances grid flexibility and reliability, supporting the transition to a more sustainable and renewable energy system. Okay. And this V2G technology, it reduction in electricity cost and price volatility. Okay, so therefore price fluctuation, the electricity price fluctuation we can avoid, and then we can reduce the electricity cost by going for this V2G technology. Okay, there are other benefits are also there in a vehicle to grid technology. Financial benefits for EV owners, grid stabilization and peak demand support, supporting the balance of supply and demand. Okay, lower carbon emissions and cleaner energy mix. Okay, these are all some of the advantages, benefits. Okay, and so that there are countries like Japan and then UK. Okay, they have implemented, they are getting benefit. I have highlighted. Okay, I think so that from madam you can the participants, you can get the PowerPoint. Okay, so I given the PowerPoint to madam, you please get it, and then okay, you can so that again read through the PowerPoint. Okay, the applications of V2G technology. So it is not only this V2X. Okay, it is electric vehicle fleet management, grid ancillary services, smart home integration, intelligent energy trading, and then so it is to truly harness the potential of V2G in electric vehicle fleet management services from pulse energy, provide the essential technology and the support required for seamless integration and optimal energy utilization. You see, so in the diagram, you can understand. Okay, V2G, it is for generation of power, and then for the grid. Okay, and then even we can integrate that other renewable sources with the V2G technology. Okay. These are all the types of vehicle to grid systems. Okay, unidirectional power flow V1G, bidirectional power flows, and fully bidirectional V2G. I have given some examples also. V1G. So currently in our country, Ola, TVS, okay, Revolt, okay, these are all some two wheelers. Okay, these are all unidirectional power flow only, and bidirectional only in so that the developing stage. Okay, Nissan Leaf, it is the best example for the bidirectional. In foreign countries like in UK and USA, they are using this. Japan, okay, and Korea also, so that they are using this V2G technology vehicles, e-vehicles. Okay, Kia EV9, okay, it is a fully bidirectional V2G. Okay, there are several challenges are also there in implementing this V2G. Okay, challenges and obstacles. Okay, despite all the benefits, V2G also has its own challenges before implementing its this throughout. It is okay. So therefore, you should know. One is current limitations of vehicle and charging stations. That is the one thing. Second one is the lack of consistent regulations across regions. Okay, because every country they are having own regulations. So therefore, so that developing a common vehicle, okay, with V2G technology, it is very difficult. Okay, and the need for clear incentives and economic models, because it all depends upon the government policies and depending upon that government. Okay, so it differ from country to country. Concerns about EV battery lifespan, that is another one issue. Okay, if you are continuously using this V2G battery, or the battery which is used for V2X or V2G, V2H, V2L, okay, then so that the longevity, it is a problem, and the efficiency of the battery also, it is a problem. And I told you the battery disposal, it is a problem. Okay, the future of vehicle to grid technology. Okay, so there are countries. Okay, I told you it is US Department of Energy, they are working. Okay, studies suggest that increasing adoption of plug-in electric vehicles, that is PEV, and other electricity dependent technology could significantly impact the nation's power grids. Okay, and then so they want to raise by as much as 38% due to the growing demand for electricity from these sources by 2050. Standardization of protocols and regulatory support, again so it is a problem in the V2G, adopting the V2G technology, because V2G systems can seamlessly integrate with the existing infrastructure and operate efficiently across different regions. Okay, so therefore so that the regulatory rules and other things are it is okay, it is difficult for the people who are developing this V2G technology. Okay, infrastructure scaling and grid modernization, another one interesting area in the V2G technology. Okay, I am not going into that into depth. Okay, investments in the grid infrastructure for widespread V2G adoption, again it is a problem, or more investment it is required. Significant investment in grid infrastructure are needed to support widespread V2G adoption. Okay, Developments in the smart technology and EV manufacturer cooperation, that also it is required for the adoption of or development of the V2G technology. Vehicle to the grid projects around the world. There are a few countries now. I told you now it is USA, UK, okay, Japan, okay, and Korea. They are working on so this vehicle to grid projects around so in the world. Okay, so here V2G technologies are scalable as seen in initiatives like the vehicle grid integration platform in the United States. Okay. So global initiatives, okay, there are several countries they are working on V2G. They are spending money, investing money on V2G platform. Denmark also they are working on the V2G development. Okay, vehicle to everything. Okay, so here it is a very interesting. So this slide. Okay, vehicle to grid, vehicle to aids, vehicle to building, vehicle to community, vehicle to home, vehicle to load, vehicle to microgrid, vehicle to neighbor, vehicle to vehicle, and vehicle to X, vehicle to everything. Okay. Okay, again I am so that ending my PowerPoint. Okay, so with some barriers. What are the barriers in V2G adoption? There are several barriers are there. Okay, but there is one interesting research paper in which they have listed out nearly some 23 barriers for V2G adoption. Low EV penetration rate, that is the main barrier. Okay, and complex technology for V2G chargers, complex optimizations for energy management system. Why I am highlighting all these barriers means you can work on it. So taking the first barrier, how to, yes, e-vehicle it is there, e-vehicle there are advantages are there, there are certain disadvantages are there. And then in the e-vehicle we can go for bidirectional charging. It is called V2G technology or V2X. Even in the V2G or V2X there are some several issues are there. I am highlighting that issue. You can address that issue. So therefore I am addressing both what is the problem in the EV and what are the advancement in EV, and then what are the advancement in V2G, or what are the issues in V2G. So therefore there are some four interesting areas which I am so that floating today. So therefore you can so that work on some different informations or different techniques for your research and for your undergraduate and postgraduate guidance. Okay, competing technological solutions, new and complex communication standard between electric vehicles and chargers, communication standard to control chargers, cyber security, okay, privacy, range anxiety, lack of understanding, control over the charging process, battery degradation. I told you now, because continuously if you are using this for V2G application or V2X application means battery will get degraded, efficiency will go down. Okay, and then some issues will come. Okay, so therefore how to avoid it or how to overcome it. Okay, in the e-vehicle itself the battery there is a problem, but if you are going for the advancement V2G adoption, again battery is facing another one problem. Okay, so therefore that battery management, battery development, and minimize the battery degradation, it is an important area. Uncertain V2G profits for EV users. Okay, long value chain, cost of V2G chargers, because it is a binary charger. Okay, so that binary charger also we can work. Okay, I told you now it is some 23 barriers. Okay, difficulty energy trading and balancing. Okay, interaction with the parking and the charging, absence of a business case for organizers, taxation it is a issue, communication between charging service sectors, lack of V2G capable, okay, EVs, failure to secure a critical mass of early adopters of V2G, lack of large scale demonstrations. Okay, like this. Okay, there are several barriers are also there. But even though there are barriers also are there, okay, there are certain countries they are working on V2G. Even our country, IIT Mumbai, and then so that the Central Electricity Authority, they are working on it. Okay, so therefore you please, okay, so that there are several options are available, so that the development of e-vehicle, okay, how to overcome the barriers in e-vehicle and how to improve the batteries and the charging station. Even you can become a entrepreneur, and then going for V2X and V2G. Okay, again it is a opportunity to become an entrepreneur. Okay. Conclusions on V2G technology from the performed research, it can be concluded that the adoption of V2G technology is a complex issue that still has a considerable number of significant barriers to overcome, requiring the collaboration of different stakeholders. Okay, so therefore, engineering, science, okay, and then technology, even so that the management people they can work on, okay, because that is why I put requiring the collaboration of different stakeholders. Okay, all these, okay, even so that the vehicle users, vehicle manufacturers, vehicle sellers, all their input it is required to overcome all hurdles and barriers. Okay, the current paper has identified 23 barriers. I told you na, so that the one of the research paper, 23 barriers they have listed out, potentially hampering the adoption of V2G technology, including technical, business, and EV users related challenges. Okay, you please go through that the paper. Okay, it is available in the website. You can download. Just you put that 23 barriers. Okay, in the V2G technology, you will get that paper. Furthermore, the analysis of the identified barriers has defined the risk for non-adoption of V2G technology associated with the energy barrier, along with the influence and dependence of every barrier on the others. Okay. EV charging integration infrastructure connected to grid. Okay, so in first for India, okay, there is a software. It is developed a software company, Sheru, so that they are developing a V2G bidirectional battery swapping system to balance demand as the country's electrical grid continues to strain. Okay, so that they are it is a software company, but they are working on so this V2G bidirectional battery. Okay, and they are working on how to connect this V2G with IoT and the smart sensors and the smart cities. Okay, EV to grid integration. Okay, I am leaving all these things. Okay, final remarks. EVs, electric vehicles, can help India build smarter, more sustainable cities. The potential of technologies, okay, like IoT, big data, and artificial intelligence, and of course, machine learning, deep learning for urban infrastructure, which include EV charging infrastructure in smart cities to be properly utilized. Okay, a robust infrastructure of systems, devices, and communication networks is necessary to effectively capture, process, and disseminate data across different sources and support the integration of physical infrastructure. EV adoption is quasi impossible without the backing of specific government policies. Okay, good government policies. Of course, government of India, they are encouraging 10,000 crores they are spending. Okay, if someone is interested, please approach, and then you can get a large projects also in a cloudy regulatory environment. The integration of EVs and smart cities will be more challenging. Okay, for automakers, V2G functionality requires specialized hardware, primarily in the form of a bidirectional inverter, in addition to accompanying software. Okay, as a result, V2G integration carries a higher cost for manufacturers, which can limit its inclusion to specific models and trim levels. Okay, V2G technology offers a transformative bridge between electric vehicles and energy grids, promising enhanced grid stability and sustainability. While India's readiness for V2G integration shows promise, addressing infrastructure challenges and fostering regulatory alignment is pivotal for propelling this innovation towards a sustainable world or sustainable India. There are several solutions are there. Okay, finally I am ending with this. Okay, integrate the EV ecosystem into smart city technology, support the implementation of electric vehicle and smart city technology with the government efforts. Okay, public acceptance solutions. Okay, the path to these are all the path to sustainable and efficient transportation in smart cities. Okay, I think so that I have covered. Okay, so in the allotted time, so 1 hour 30 minutes. Of course, we have started little bit late only. In so that 1 hour 10 minutes, I so that made some justification. Only just I will conclude. Okay, so that transport it is very important, and then there are several options are available. Okay, but in the transport there are several issues are there. So that to overcome the issues, we are going for electric vehicle, hybrid vehicle. In the electric vehicle also there are certain issues are also there, barriers are also there, that we can do it as a research work. and there are some advancements in the e-vehicles. It is possible. One such advancement is called the V2G technology or V2X. Okay, I have given so that enough information about the V2G. Okay, there are papers and the reports are available. You please go through it. Okay, please okay, do some work on V2G technology. Thank you for supporting electric vehicles. Okay, thank you.
Thank you, sir. Thank you
Thank
for the interesting and informative session on electric vehicle as well as vehicle to grid technology. And we have learned more about vehicle to everything. Thank you once again, sir.
Thank
Any
you.
questions
Thank you,
from the
ma'am.
participants?
Audience, any queries?
No queries, but the presentation is very clear and nice. Very,
Okay, madam.
very fine
Okay.
presentations.
Thank you, madam. Thank you.
Sir, I thank you for the appreciation given for Dakshashila University and also for the title what we have chosen for the 13 sessions. Thank you for the appreciation, sir.
Okay.
Sir, I have a question, sir.
Please, madam.
Yes, sir.
Is it
You
visible,
have
madam?
stated that. Yes, sir.
Yes, yes.
You have stated that for electric vehicle, you can also use Wi-Fi to charge. Whether it is in usage or whether it's in research stage, sir.
No, madam. So that even so that normal our mobile phone, we can use it.
Yes.
So it is some control, na? It is some control system. That's all. So network, so that already suppose in my system or in my mobile, I am giving some of the information, timing and other things. Then it will pass on the information because that is what I said. Now it is some Internet of Things. Okay, IoT and other sensors and other devices. It is required to control. Okay, for the bidirectional charge, because if I am fitting that. The devices, the sensing devices or communication. So it is actually it is connected with the communication also. That communication devices, if I am connecting, so if I am passing this information means then it will take and then so that it will whether it is to charge or discharge, it will decide.
Whether it is in
So
usage, sir, now in India.
yes, madam. Yes, madam. So it is in usage. Usage means it is not in our country.
Yes, sir.
People
That's
in
what I
IIT
must.
Mumbai, they are using it. In Mumbai, so they are trying with some Wi-Fi. Wi-Fi means it is some the mobile phone. They are so that they are doing that bidirectional. They are giving some command. Okay, giving some command only. Na, it is nothing other than that. For the charging station
Thank you,
and
sir.
for the yes, madam. Okay, okay. Thank you.
Thank you for your nice presentation, sir.
Okay, okay. Any other queries? If any, so that if there is no other queries, madam, then please conclude with some formal vote of thanks, madam.
Okay, sir. Sir, hereby I thank Dr. N. Alagamurthy, sir, from Pondicherry Technical University. And also I thank the participants and also the co-coordinator Sri Vidya and then Prasanna Kumar and Dean of Faculty of Engineering and Technology. I thank you. And the participants stay in the meeting for the next session. Thank you, sir.
Thank you, madam. Okay, I am leaving. Okay, bye.
Yes, sir.
Best
Bye,
wishes
sir.
for all. Best wishes for all. Thank you.
Thank you, sir.